Hi, everyone. Thanks for coming back to Technology Envoy. Today, I have a very special guest back. This is going to be the fifth interview with Chris Beskar, the CEO of Stavatti Aerospace. So how you doing today, Chris?
I'm doing great. Thanks so much for having me today.
That's great. And we also have Brendan here. Brendan is the CEO of the Starburst Foundation that was first started by Paul Laviolette. And it's all about subquantum kinetics, a physics thing that Paul Laviolette has worked on all his life, and Paul's now passed. So Brandon and I and a few of the others are kind of carrying on his work, and it was really amazing, Chris, because this is actually our second interview today because you were in the group with us in the physics group this morning with us, talking to everyone, and that was really amazing. So I have to want to thank you for that
You're
very
welcome.
much. Yeah. Um, Today we'd like to jump into probably more the airliner, the SM-920, and all your plans and whatnot. So we've got some slides ready,
Mhm.
and we'll let Brandon go with those, and then we'll ask you a few questions.
Sure.
So this is the SM-39 Razor, most amazing plane ever, I believe. This is my favorite, actually, maybe other than the hover car. Um, and I haven't seen what that looks like yet, but this is basically like an SR-71 on steroids, maybe.
Yeah, it kind of is. It's a high speed uh air dominance fighter, kind of like a YF-12, the version of the SR-71 that was planned to be an interceptor.
Yep.
And this is a little shorter than a YF-12. It's designed to fit on a carrier deck, so it has
Okay.
dimensions very similar to an A5 Vigilante in that sense, with a 53-foot wingspan and a length of about 70 feet from nozzle to nose.
Yeah.
And the maximum takeoff weight as a carrier aircraft is about 80,000 pounds, but as
Okay.
a land-based fighter, it's about 105,000 pounds. And kind of all the rage is this discussion of a bunker buster bomb. This
Yes.
plane could carry one bunker buster bomb along its center line.
Oh,
Uh,
interesting. Okay.
so you could mount that externally,
At
or as a bomber version, there is a version that would have a longer weapons bay to carry the hypersonic missiles or a bunker buster bomb internally. So that kind of gives you an idea. But the weight maximum warload is about 25 to 30,000 pounds.
So basically, like they used the B2 yes last night essentially, or three B2s
Right.
last night, and you're saying, and they carried two of those bunker busters, so this could carry one. But the thing that came into my head right away is you're carrying one bunker buster at Mach 4 plus.
Yeah. Yeah.
Wow, right? I mean,
So
how fast is a B2? It's
about 0.87 Mach, about
yeah,
just under the
exactly,
speed of
right?
sound. Yeah.
That's wow, that's a whole big difference there,
So
isn't it?
yeah,
Yeah.
and the combat radius, of course, depends on fuel load and speed and payload. But you can trade internal weapons capacity for fuel capacity, and like in a carrier operation, the weight is limited due to the carrier elevators and due to the catapult launch system and of
Y-
course the resting cables.
Right, right. Yeah, right. Yeah, because you got to get it off the deck. I was telling you about some of my military friends, and young George, who's a Marine, the Navy just said that they're going to make him a pilot. So he's actually going to be landing on these carriers, which is very cool. Maybe one day he'll be flying your planes. As a matter of fact, he's
Indeed.
your number one, like he loves you,
Oh,
basically.
cool.
Yeah, yeah, very cool. That's young George. Yeah. So yeah, that's the SM-39. What do we got for the next one here, Brandon? Okay, yeah, let's talk about this. This is some amazing stuff.
Sure. Well, okay. So right now, Stavatti owns a facility in Niagara Falls, New York, at the Niagara Falls International Airport. So it's an airport property with direct access to the runways and the ramp and the taxiways. We've got about roughly 180,000 square feet and that includes a large 125,000 square foot facility with a hangar and multiple offices. You can see the background of the
Yeah, the hangars behind you. Yeah.
so that's roughly, well, it's hard to measure exactly, but because we keep finding space, and
Well,
it's
that's
about
good.
it's an old facility. It's about 47,000 square feet, I think, of hangar floor. So it's a big hangar. We can house 12 jet fighters or one 737 or a C-130 or something like that. So
Okay.
it's good for prototyping. So we have our prototyping center here. We've got 20 acres roughly, about 19.52 acres, which is enough space to build even larger hangars.
Okay.
So that this is our prototyping and engineering development center. However, we really don't have space to manufacture aircraft, especially airliners.
Yeah.
So we do need to build a new plant, and so we have been working on the design of this new plant. This is one of our concept images that came out some years ago before we started the architectural development and the
Okay.
site selection. So we're currently in the process of site selection
Yeah.
as well as design for a plant. And yeah, the idea is that between 2026 and 2028, we'll select our site and we'll start groundbreaking on this large facility, which has a footprint of about a million square feet and about 2 million square feet if you were to add up all the office space and everything else. And
Wow, that's
this
huge.
now this little image you see, we actually laid out a hypothetical situation where this is set up at the San Bernardino International Airport. There is some land at that airport at which we could establish this facility, but
Hmm.
we're looking at about 15 different sites,
Oh,
maybe
wow.
and in different states we're engaged with, everyone from Texas to Florida to North Carolina to of course New York, where we're currently at Niagara Falls. But
Yeah.
you know,
Wyoming?
Wyoming is a possibility.
Yeah.
I think we definitely want to have a presence in Wyoming, probably a center and some hangars. It could be a manufacturing site, but the challenge is that we need about 15,000 people to produce the
Wow.
commercial airliner. And so if we were to set up in Wyoming, that would really be a big employer for the region. And I don't know if we can support 15,000 people in any particular spot in Wyoming at the moment. So that would be,
Yeah, that's true. Yeah.
there's other places that really have that community. Not to say anything negative about Wyoming, but it's on our site selection list. So
Yeah.
there's
Very, very cool.
mhm.
So three different planes at the same time. That's why there's three different wings of this building.
Yeah, the idea is that this would be home to our commercial and military and general aviation production. So we could produce three or more aircraft simultaneously, and it's sort of modular in a way. Certainly can expand it out, and we have engineering, design, and machining integrated. But at the same time, a lot of our business model really rests upon integration of systems that are produced by a supply chain. And
Right.
so we outsource to a very expansive supply chain of well-known companies and their support companies, and then smaller companies that do machining or individual parts production. And then everything's integrated. That said, for some things we'll be producing in-house and other things we'll be outsourcing. So it's not solely raw materials come in and our airplane comes out. It's a lot of systems that are acquired and delivered to us.
Yeah.
And so that's a big part of it.
Just thinking about the 15,000 people, and like I went to a tech school,
Mhm.
technology school. I think that's what in the future a lot more people should consider
Mhm.
doing for a career. Because if you want an engineering type job, that's probably the best route. Um, you got hands-on where you're actually doing the building of things, prototypes, but you can also do the theory part as well, because that's what an engineering technologist does, and that's what I am essentially, right?
Mhm.
Um, one thing I'll put this past you, Chris. live on camera here. One thing that I've always wanted to say to you was my dream would be to have something called the Beskar Institute of Technology. So essentially a school
Mhm.
that would teach all of these aerospace skills that are going to be necessary to work for a company like yours, right?
Well, we can talk about that. And that's something that one of our directors, John Simon, is really on top of because we've already started what's called a PTIC program. And that started, gosh, maybe 3 or 4 years ago, which was a partnership with some of the technical colleges in the Buffalo, Niagara area, as well as the high school. We have a high school program that we've been doing now for
Cool.
3 years. And it starts at, well, there's an eighth grade program. So John can actually, he can talk about it far better than I can, but we've been working and we actually secured about $2 million, I think, in grants from New York to do this program for colleges and technical schools.
Oh, that's amazing.
It's been a neat, so we already started that, and it's ultimately oriented at creating a workforce for Stavatti, but it's also good for the whole community. Uh,
Definitely.
and then we started getting into the whole idea of creating basically an aerospace, Stavatti Aerospace high school or technical school.
Yeah,
Uh,
yeah.
and so really getting into an aerospace academy, that's been something we've been thinking about, in particular in some areas. I mean, yeah,
Geez, I'll be your first student.
so it is a lot of fun, and we're fortunate that we have some people that are heavily into education on our team. People like Stu Cart and others. So
Oh, very
they're
cool.
they're very keen on education. So
That is amazing. Yeah, because this is the future that we're talking about, and without those skilled laborers, machinists, engineers, technologists, you can't build things. You need to have that. Machines will do a certain amount. We were talking about the DED, directed energy deposition, and 5-axis machines and whatnot. They can do a lot of things, but you still need that person to program it and you know have the skills, right?
so looking at when I say 15,000 people, and that number is kind of a lowball number on the airliner project, but
Wow.
uh, of those 15,000 people, about 2,000 to 3,000 people are what you'd consider uh, engineers and the high end technical people.
Yeah.
About 13,000 are assembly people, and that
Yeah.
ranges from assembly, machining, the production. It's the production crew.
Yeah.
That production crew, if it wasn't for advances in robotics and efficiency and new technology, it'd be up to 30,000 people.
Wow.
So, so to do what we're doing, and even a lot can be said for the engineering staff. We don't need that many people to produce airplanes anymore compared to where we used to be.
Yeah. Yeah, like World War II or whatever.
World
Yeah.
War II. So, and using our manufacturing approach, which is more focused on mass production, the numbers uh, drop quite a bit in terms of our employment needs. But because of the volumes we're looking at, it's still a fairly good number. And so it's not as low as it could be. And there could be robotics that come into play. But even with robotics, then you get into the need for programmers, you get into the need for people to maintain the robots.
Yep.
So you're not going to have a severe reduction. I mean, in our situation, I don't ever not see employing 15,000 people, but we might not employ 100,000.
Right.
That's kind of the big distinction.
Yeah. And you said you've got 15 different sites that you're looking at. So, I mean, safe to say that you might want to reproduce this at different places once things get rolling, right?
Well, with respect to our airliner project, and that, we can talk about this further as we move along, but we have a need to build two of these facilities, one in the United States and one outside the United States.
Okay.
So there's already that need, and the employment levels will be about the same. So we're looking at about employing about 30,000 people.
Wow. That
And
that's a
this,
lot of that's a lot of
yeah,
people.
so that's direct employment. Indirectly, it's quite a bit more. You can give it maybe a five-fold multiplier. So you might be looking at about 150,000 people. And that would be everybody who might work for Raytheon Technologies that supports our projects to smaller machine shops and other companies. So
Yeah. Wow, that's amazing.
a big economic impact.
Yeah, definitely. What's on the next one? I think the next one actually shows some of the projects you're just talking about, like the airliner, the Razor, and the Stiletto.
Sure. Yeah, well, so this is kind of an important slide, and of course, at the
Hmm.
Dominance Summit, we wanted to draw people's attention to this. So, in the airplane business, as opposed to other things that we're focused on, but just what I'd say the conventional fixed wing airplane business, we have really three primary projects that are our main concentrations. We have a lot going on, but this is what we're really concentrating on.
Yep.
Of course, the Stiletto trainer, which we're one of the prime contractors competing for the Navy undergraduate jet training system. And that's
Okay.
an airplane to replace the T-45. And this airplane is a lot like an F-5 or a T-38, and it's really focused on export. We project about 1,500 sales worldwide of
Wow.
this particular airplane. And so it's a good light fighter. It's very affordable.
Yeah,
Uh,
the
you know,
23 million looks like a pretty good deal, right?
And so that's that particular project, and that's a big priority project, and we need to get the prototype flying in the next 24 months, if not sooner. So
Okay.
that's a big priority. Then, of course, we have a Razor, which is our air dominance fighter, and our business model is really to focus on an airplane that can replace F-15s. And when this presentation was put together for the Air Dominance Summit, it had just been released that the Air Force had awarded a contract to Boeing for the F-47.
Right. Yeah.
And Stavatti wasn't exactly competing for that competition. We didn't submit any RFP response for that because we have a slightly different mission. The F-47 is kind of an F-22 replacement, sort of.
Okay.
That's the best way we can describe it. And their numbers, they're looking at about 185 airplanes, roughly.
Yeah.
Uh, we have a different business model completely. We're looking at replacing F-15s, and that's, about 1,800 sales worldwide. And our price point is different. We're at 85 million. And so it's a different kind of business model entirely. So this is really more suitable for, say, a Navy aircraft or for a
Okay.
aircraft to replace foreign F-15s. And then, of course, the big project that
Yeah.
we're very excited about is our airliner, the SM-920 Airliner, which is a 737 replacement. At the time, when we gave this presentation, we were really looking at a market of about 8,000 airplanes. Then I did some traveling, met with some strategic partners outside of the United States.
Yeah.
And they made a commitment, and we entered into an agreement, a cooperation agreement. And it's to provide $4 billion in development funding, as well as production guarantees for this particular airliner. And so that was launched. And
Wow.
right now we're looking at producing about 8,500 airplanes in the United States, if not more. And this is over a 20-year period.
Okay.
We're planning this airplane to enter production in about 2031 and continue production through probably about 50 years.
Oh,
So,
wow.
I don't really, when if you to do more than a 20-year market projection is tough.
Yeah.
But if you look at the 737 or the Airbus A320, they already have a backlog of an additional 10,000 planes when you combine the two. Uh,
Wow.
so when we say 10,000 sales worldwide, I think it's realistic over the next 20 to 30 to 40 years. And that's kind of the time frame we're looking at. And of course, 1,500 produced minimum outside of the United States, and then 8,000, about 8,500 produced here. So it's a big possibility. And of course, it's a direct competitor to Boeing. Um,
Yeah.
since this announcement, Boeing has announced that they're planning on moving forward with their new 737 successor, and Airbus has announced that they're planning on an A320. I don't think that would have come out unless
Yeah.
they had
Wow.
signed their agreement. And so where we, the agreement is known to Airbus and Boeing. They know all about it. They're very
Yeah.
well aware. The supply chain is aware of it. Everybody should be aware of it. Um, but like I said in our previous call, we're not really sending out any news releases to Aviation Week. We're just focused on getting this really prototyped. And so we're on a fast track schedule for these three primary airplanes. And then there's all the other airplanes that we're focused on too. But as far as the big programs, this is our core. So
Yeah. And so you said 2031 for this. So basically, the hover car and this is going to be about the same time for actual production to come out.
about the same time, yeah. And so there's going to be a little bit of a disparity because you have one vehicle that can kind of put the airliner out of business, and the other,
Yep.
but there again, it's trying to figure out how everything fits into place. And there's still going to be a need for wide body airliners and a need for, just because people own cars doesn't mean the bus industry goes out of business. So
Yeah, exactly. Yeah, exactly. Oh wow, that's amazing. So basically, these are the three primary programs that you're looking to the future for, essentially.
yeah.
Yeah, very cool. I think that on the next slide, there might just be a shot of yeah, that's the SM-31 Stiletto, I think.
Yeah, that's the S model, the fighter version. That is kind of our F5, F20 type airplane. It's really more like an F20.
Yeah,
You're familiar with that airplane?
very, very cool. And Brendan, on the next one, yeah, here's a little bit more about the SM-39. The reason why I brought this up was cost per flight hour. Um, there's, it seems like that's a pretty good deal compared to other things.
For a fighter, it is. And if you look at F-22s and F-15s, the F-22 is quite a bit more expensive than this. It's in the well, we have those exact numbers in another slide, but it's in the $30,000 to $40,000 an hour range. F-15s have dropped in cost per flight
Okay,
hour to around 18,000.
so this
So
is cheaper than an F-15.
this is cheaper than an F-15, and a lot of that has to do with
Wow.
engine parts count. Avionics systems are a big part, and airframe maintainability, the reliability of components. And when you compare it to, say, an F-22, that uses a different approach to stealth and low observability
Yeah,
that that is very maintenance oriented. And there's a lot of
the coatings
yeah, the
and
coatings and all that, and it's really not suitable for one, naval operations, and two,
yeah,
for for maintainability. So this is more of a carefree maintenance system on observability, and so we're pleased about that. So you want to drive that cost down as much as you can. Of course, how you maintain it has a lot to do with your military structures. So really, when we quote these numbers, they're not exactly hard numbers, they're relative numbers. So just
yeah,
like you'll get an exact number of, say, $18,210 for a F-15,
yeah,
it's probably never that number. But it just gives you this relative idea of this airplane's cheaper to maintain than the other one.
yeah. And part of I know that this is built out of a special material. I think there's going to be another slide that talks about the titanium diboride foam structure.
Yeah.
Yeah, I think it might be the next one. No, this one just talks a little bit more about all the specifications for the plane. Yeah, here it is right here. You can maybe
Yeah.
talk a bit more about that because I think the first time I saw this was it was a release right a day before we did a show together, and I brought it up or whatever, and it was from DARPA. You had submitted this to
Yeah.
DARPA, I believe, right?
Yeah, so this has been something we've been focused on for a long time, since really 2012. That's when we made our big changeover.
Okay.
In about I've been very focused on composites for many, many years, and the composites technology was starting to include things like basalt fibers, and some high temperature resins. And we have two very high temperature composite resins that would work very well for high performance fighters. And
Okay.
we could build the Razor entirely out of basalt fiber and a high temperature resin. And we're at that level of technology now that we could build the airplane. That said, for our particular mission and the longevity of the airplane, we decided to go with this titanium foam metal sandwich and titanium diboride skins. And the titanium diboride is a metal matrix ceramic that is both high temperature, and it has some very amazing properties. So it's perfect for the needs of the Razor and other high performance aircraft and spacecraft. So
Ooh,
there's certain
cool.
things that, the foam metal sandwich technology itself, there's been a lot of work on it from a ballistic standpoint, and not just for like armor, for
Hmm.
survivability against bullets, but really for micrometeor impacts.
Oh, interesting. Yes.
So this is really important if you're going to build a spaceship or a space.
Yeah, spacecraft.
And honeycomb is great, and you see honeycomb throughout the early NASA space capsules, all of them. I mean, Honeywell is used throughout the aerospace industry, especially for space vehicles. Challenge with honeycomb is that it has huge open gaps,
Yeah,
and you
yeah,
know almost 99% of it is penetratable by a meteor. So
yeah, definitely.
so with all the space junk and micrometeors out there, you need something that can provide a layer of protection. And so we can adjust the density of the foam. And it's very similar conceptually to having a surfboard. You have a foam and then you have fiberglass. Well,
Yeah,
uh, and that's kind of how I grew up with airplanes. You can go into your hangar or your basement to your garage and carve yourself a shape and then fiberglass it, and voila, you have a surfboard or an airplane.
yeah,
Uh, and This is more sophisticated than that, but it's conceptually the same thing. It's a foam and it's metal or metal ceramic. And
metal
so
ceramic. Yeah.
that's really neat. And so we reduce a lot of parts count. And so if you look at the internal structure of our airplanes, there's less stuff inside structurally because more of the strength is in the skin.
Oh, okay.
Some of our images are a little deceptive because we actually have fewer bulkheads than are in here. And so,
Yep,
like our stiletto airplane, that will be a honeycomb sandwich aircraft. And
yep,
that's really not a combat airplane. It is a fighter, but it's not intended to go into close support type missions.
yeah,
Um, and it has a different role.
yeah,
The Razor, however, is far faster. It's more sophisticated, and it is intended to go into heavy combat. And so, having something that's very survivable, very resistant to vibration is all important. And the other important consideration with the Razor, other than temperature, is, and of course, the low observability features just is the stiffness of the design and its ability to operate at very high altitudes. So you want,
yeah,
skins that are suitable for that with the foam structure.
yeah. The other thing I noticed here too, because I know about Scandia aluminum,
Yep, yep.
which was the Russian thing, right? But you've got scandium titanium alloy. What's up with that?
So that gets into and you brought up Pete Peterson in the past. So
Yep.
um, we covered, I think, in past interviews the discussion about Asher's technology and the proliferation of scandium technology into the United States from Ukraine that began in the 1990s.
Hmm.
And so we brought that technology over through a company that was both an Air Force and CIA and private sector initiative. Well, that was in concert with a Institute for Materials Science in Ukraine, Kiev.
Oh, okay.
And I had gone back to Kiev in 2017 and met with them a second time for myself personally.
Yeah.
And we concentrated upon where they were at. And since then, since the 90s, they had focused on scandium titanium alloys, and they're very
Wow.
excited about that. And so that's something that we've been able to incorporate into our design and development. And we have an office in Ukraine. It's more of a technology office. We have
I
some relationships with their engineering departments and all that.
Yeah, I knew about that
Um,
actually. Yep.
so that's where a lot of that came from. And so we were pushing for kind of a material science deal because there's two major sites to produce scandium in Ukraine. And
Oh,
when you hear on the news that there's a mineral deal, resources deal in the works, that
yep.
ties into that. So there's certain resources that Ukraine
Oh,
has that the reality is that if Ukraine shifted their focus and they concentrated upon advanced technology and industrialization and mining, they could probably be one of the wealthiest countries in Europe.
yeah,
So they go from being extremely not wealthy to one of the dominant players.
yep.
And that's just reality. And they have the resources to do that. Of course, we may have the resources to do that in Wisconsin too. So I don't know, so it's kind of fun.
Yeah.
And since talking to the Ukrainians, there's been more and more sites in America that have found to have scandium. There's even
Oh,
scandium in the hills of the Nevada test range. So
no way. Wow.
yeah, so we could just do a lot of this domestically. But yeah, so scandium, titanium, scandium, aluminum, lithium, titanium diboride, those more advanced alloys are very critical. And those don't touch on the super alloys. Those are just pretty straightforward, relatively speaking, uh, approaches to new alloys that give you better performance in terms of strength and structural
That
weight
that's
ratio.
interesting. I took metallurgy when I took engineering. What can you talk a little more about a superalloy or give us an example of that? That's fascinating to
Well,
me.
like Inconel is a super alloy.
Okay. Yeah,
And we
yeah.
have, we have different super alloys in aerospace, past
Hmm.
developments that and that are go beyond your traditional, say, titanium alloys or your
Yeah.
aluminum aircraft alloys. And so these are the cobalt, chromium, nickel alloys. Um, we have our own line of alloys that we've been really tinkering with since the early 2000s
Oh,
and late
wow.
90s. And this gets into what is a Beskar metal,
Yeah, I
so
was just about
kind
to
of fun.
say that.
So
Beskar armor.
a
Or
Beskar metal has, three elements in it that you usually don't find in aircraft alloys, and
okay.
or high strength to weight ratio. And there was some talk of different high performance alloys out of the Idaho National Labs that they were focused on, and you can look up if you were to Google alloy that's as strong as titanium, but half the weight of aluminum or something like that.
Hmm.
Those exist, and it's a matter of
Wow.
producing them. So that's a lot of fun, and it's just not too popular. But super alloys, especially in jet engines, is really critical. Of course, then you have your metal ceramics like titanium diborides, and it
Yeah.
you know
Didn't you say once before that you can use that in your engines that you're going to build?
yes, yeah, that's a
Yeah.
big part of what we're doing. That's so the engines that we're building for the aircraft, and the engine came out of a need to build a Mach 4 airplane. If you
Yeah.
have so this is a little different than what General Electric and Pratt and Whitney are working on. And it and I don't know if you have a slide about the engine technology, but if you
Yeah, I'm
do,
not sure. I
I
added it. I'm not sure that I added that one in there. Yeah. Yeah.
well, basically, what it boils down to is to advance engines. There's really a few things you can do. One is improve the material science, which is
Yep.
what we focused on. The other is to improve the aerodynamics of the engine itself, and that
Okay.
is with blisk fans and new compressor blade technology and advancements in internal configuration. Then
Yeah.
you can change the combustion process. You
Okay.
can use enhanced combustion technologies or new combustion chamber designs or plasma combustion or more advanced combustions.
Oh, wow.
Then you can play with the physics of what's coming out. You
Yes.
bombard your exhaust with electrons. You can manipulate more of the physical characteristics of your exhaust. And so those are really the four major areas you can do improvements in jet engines.
Yeah.
And part of it is gets into the cycle. And you'll hear now like the F-47 will have a variable cycle engine. Well, we've been very focused on variable cycle at Stavatti for years, and we're glad to hear that because one of the competitors for the ATF program, which resulted in the F-22, General Electric had a variable cycle engine, the YF-120,
Okay.
and that was deemed too technologically risky back then,
Oh, wow.
although it wasn't. I mean, in our opinion, it was a great engine to develop and pursue, and so that's where we
Yeah.
concentrated our energy. And the issue now is can either Pratt and Whitney or GE produce an engine for our aircraft that would have the performance characteristics we need specifically for the Razor?
Yeah.
Now, most of the airplanes we're working on use off-the-shelf engines. You don't need anything exotic like the SM-31 uses a proven engine. The airliner can use a proven engine, but
Yeah.
the airliner can also use a more advanced derivative engine from what we're developing. So getting in
Yeah.
the engine business is important to us, and we've concentrated heavily on the materials aspect, but really the four aspects I mentioned. So to really be a competitor. But if
Yeah.
somebody has a better engine, hey, we love to talk to them, so we don't have to focus on engines. So
Yeah. Yeah. But I think it's really cool that you're developing your own essentially, because I think that's just something that has to happen. It's like Formula One.
mhm.
There was engine builders and there was car builders, but Ferrari always did both, and
Right.
they've always been at the cutting edge of everything, essentially, right? Yeah,
Certainly
cool.
do.
What do we got for the next one, Brandon? Oh yeah, I brought this up just because I saw the address of the Wyoming uh, different offices that you have and whatnot that we've talked about and whatnot. So um,
Yeah, yeah. Our main center is in Niagara Falls, and
and that a picture of it down at the bottom there?
that's a picture of a rendering of a site that we put a deposit on to acquire that we will be remodeling. So that's an image of our one of our planning images of a site.
Oh, very cool. So you purchased this and you're already working on renovating it and
Yeah, we're in the process of acquiring it. Yeah.
wow. Well, that's even more cool news. And that's why we're here too, is to talk about all the new exciting things that you're doing and how you're reaching out and whatnot. And talking about the technologies is always really cool because that's my thing essentially, right? Yeah, definitely. Um, I have yeah. Oh yeah, this okay. This is I remember
Yeah.
talking to you after I texted you and said, "Hey, how to go at the conference that you had in Nevada," and then you told me that it went really well. And then recently you put this out on
Yeah.
X.
Mhm.
Yeah, that
So this
basically talks about the whole thing. Yeah, go ahead.
Yeah, this kind of is self-explanatory. We put this out as a news release. It's not, we have another one that's called the deal summary that gets into the specifics of the deal itself. But this is just a general news release on where we're at with our airliner project. And so we did enter into a strategic cooperation agreement with uh, a a firm that's not in the United States, but they're in the Middle East.
Okay.
And it's known, over the last few months, we've had a lot of commitments from foreign governments to invest significantly into the United States.
Yeah.
And this ties into one of those relationships. And so this is a very helpful relationship for Stavatti and the United States. It also helps the country, which is investing in production outside of the United States. Uh,
Hmm.
it's a very big deal in that sense. And this is on the order of something that it's a bigger launch than many companies have ever received. So I'm very excited about it. It's certainly puts us on the Boeing and Airbus level of competitiveness. Um,
Yeah,
so it's quite an announcement. Although at the same time, we put this on our website and on Twitter, but we're not really pushing it out there.
yeah,
We still want to keep in the background as much as possible because we're getting a lot of competition,
yeah.
and it's not a fun environment. We've had parties attack us and reach out to the media and really try to
Yeah,
be a big detractor and make a lot of ridiculous claims that then you have to go fight. And we have
yeah.
but we're
I've
we're
seen,
surviving and
yeah,
continuing. So
yeah. I've seen some of that stuff,
yeah,
and to be honest, I've had personal attacks, even just because I'm talking about stuff too. But it has to carry on. These guys, it's just noise, background
yeah.
noise to me, essentially, right? Yeah.
Well, that's how it is. So anyways, we're very excited about this, and the this particular group owns a few American car companies. And
Oh,
and they own one particular brand of cars that they're reintroducing that was from the 1930s. And I won't talk about it now because it's their business. Uh,
wow.
we were really excited about it. And when we went into their office and saw what they were doing, we've already opened an office in the foreign country. And, I've been asked to provide all kinds of support materials, be it everything from mostly posters and graphic arts and stuff to build
Okay.
the office type stuff.
Yeah.
And so that's kind of cool. But we were pleased to see what they're doing with respect to cars. And
Hmm.
the auto industry has really taken off in a lot of ways. And there are some older names of cars, historic names that used to be really well known,
I,
that
I,
over the years they were bought out and disappeared. Well, now they're being brought back into business.
brought,
Unfortunately, they're being brought back into business by foreign investors, but not by America.
yeah.
But
Wow,
so
that's exciting.
yeah.
The names are going in my head. I'm not going to say anything, but yeah. Wow,
So
that's really exciting.
it was a lot of fun when we said, well, these guys are doing this and they want to be partners in Stavatti. So it's you can see where the fit is. So we're happy.
Yeah, definitely. And yeah, and so what about the hover car and these car companies too? How does that
Well,
kind of
the hover car fits in really well with what we're doing, and this strategic cooperation agreement. The airliner itself, it's a $4 billion project. The whole
four
pack,
billion? 4 billion?
4 billion, yeah,
Yeah.
and so it's a $6 billion package entirely. It includes other aircraft programs, and the hover car does fit under that category as a
Okay.
civil aircraft. So this particular agreement concentrates only on civil aircraft. There's no military initiatives. The
Yep.
military initiatives are restricted to the United States and
Okay.
export.
Oh,
So,
right. Yeah.
so this country is already an operator of. They operate military fighters provided by the United States. They've been flying U.S. fighters for, I don't know, 50 years. So they're a good U.S. ally, very close U.S. ally.
Yeah.
That said, um, while they would probably love to build a fighter plane in their country, that's not going to happen under this agreement.
Yeah.
It could under maybe a different agreement, but it's really concentrating on all scope of civil aviation. So that ties into the hover car falls under what is being called a low altitude aircraft in some countries.
Yeah. Yeah. Talk more about that because
So, so it's not really a technology issue. It's a use and integration into the airways issue.
right.
And so part of our situation with what we're doing with the hover car is twofold. We have the technology aspect, which can be very fun and exciting and pioneering. But then you also have the integrated into the society and into the airspace. And so how do you operate a vehicle like this in well, I'll just say like let's use Los Angeles as an example. Any major
Yeah,
metropolitan area where you have an international airport
yeah,
or a large controlled airspace. So you have large controlled airspace by LAX, which kind of gobbles up a lot of the airspace of Los Angeles.
yeah, that's true.
And,
Yeah,
and so you're limited in terms of how high you can fly in certain areas. And
right,
can you have a flying machine at all dropping off people at LAX?
right.
So, how do you integrate that? And so these are all FAA related questions, and it's not just FAA, it's kind of the global environment. And so there's certain countries, especially in the Middle East, that they're already starting to integrate these types of flying machines and air taxis. So,
Cool.
so there's certain places, the Middle East, China, other countries, where they're advancing the whole idea of the air taxi at a faster rate than we are here.
Yeah,
And so that's something to consider as we move forward. So it's really kind of a merger of technologies. And
yeah. So this funding that you got basically, like you said, is for civilian aircraft. So would that include the SM-150, the little sport plane as well?
yeah, yeah, and where the SM-150 is really neat, and it'll probably end up entering production before the airliner, is
Oh,
it's a technology demonstrator.
okay.
So the airliner uses the foam metal sandwich technology. Well, so does the 150. So the 150 is a quick and easy way to get that through. And we
Cool.
learned recently that it's not really, we don't need to certify the foam metal sandwich itself, but we certify the vehicle. So it's the material science of the foam metal sandwich is already proven. So we're excited about that. So that's very helpful.
Is it going to be the same titanium diboride or is it a different kind of foam metal?
With respect to the airliner, the 920 and the
Yeah.
sport plane, yeah, we don't need to use titanium diboride in the aircraft. We'll be using it in the power plants that we make,
Yeah.
especially the 150. The 150, one of the power plants we've been designing for some time is a rotary engine
Okay.
that uses titanium diboride, and the advantage of that is you don't need the seals in the rotary engine.
No way.
Yep.
Because that's the
So
problem with
that's the
them.
problem. Yeah.
Wow, that's so cool.
So we've been really on top of that one for about 5 years now, and so it's really fun. Get rid of that seal issue. So
Yeah, because you said last time that it would be about a 500 horsepower rotary engine that would probably power up the Haber car
yeah,
to get all the electronics to make it
yeah,
work. Yeah, that is so cool. I come from a big racing background, big time, and that's very cool. I'm actually an engine builder too. I did high performance for 10 years at a place called Lordco, where that's all that I did was high.
yeah, yeah,
Yeah,
Lord. Yeah.
yeah, Lordco. And I built engines, machined them, done the whole 9 yards, right?
Mhm.
Plus, I used to race snowmobiles and dirt bikes and two strokes.
Yeah.
I'm a two-stroke porter, and all that kind of stuff. I think I might have sent you a picture one time of a wheelie that I did
Mhm.
when we were talking about hydroforming because the pipes, the expansion chambers were hydroformed, and the wheelie picture really showed the the pipes well.
Yeah, yeah.
Yeah, so yeah, that's really cool.
Mhm.
Um, is there another slide, Brendan? Or is this the
No, I
last one?
think
I can't
that's
remember.
the last one.
That's the last one. Cool. Yeah, is there anything more that you want to tell us about airliner project or the civilian stuff that you're working on?
Well, sure. I don't know if there's anything else I should. Any other questions you might have? I think it's kind of we've covered a lot. Um,
Yeah, we sure have. And I really appreciate all your time. We spent quite a bit of time. There are going to be two shows actually coming out. There's going to be the one from the physics group and this one as well too. And anytime you want to show off prototypes or anything, just let me know too,
well,
especially
we
the
sure
hover
will.
car.
Well, of course. Well, to let you know kind of our schedule, we did the Air Dominance Summit in May.
Yeah.
We're going to be doing the Air Force Association show in September, which is the
Oh,
Air Force. They call it Aerospace and Cyber, and that's at the Gaylord Hotel in National Harbor, Maryland.
Okay.
That's basically Washington, D.C.
Yeah.
And then we'll be at the Miramar Air Show with a booth and a presentation. That's the same week. That's around, I think the Air Force Association show is September 22nd through the 24th.
Oh, my
And,
birthday.
oh, well, happy birthday in
Yeah,
advance.
on the 23rd. Mine's on the 23rd, so it's right in the middle of that. That's cool.
And then we'll do the Miramar Air Show, which is the 26th, 27th, and 28th, I think, in Miramar at the Naval Air Station in San Diego.
Yeah.
So we'll be there. And then we have other shows coming up too. I think we're doing a Aerospace show in Phoenix, Arizona in December. That's,
Ooh,
I think, the Aerospace Machinist or something like that.
very cool. Well,
Aerospace Manufacturing and Technology Show.
very cool. Keep us informed. We'll put out the information and all that good stuff. Definitely.
We've got that going on, and it's just right now I'm doing quite a bit of traveling. There's a lot of more additional announcements that will be made regarding the airliner, and of course the stiletto and the razor as time goes by. So.
Yeah, very, very cool. Brandon, do you have any questions for Chris? Yeah, we've been talking away here.
Um, One question I did have, I'm not sure how well you want to answer it, but I was kind of thinking in regards to the building military craft. I mean, the same applies to me as a physicist. You know, if I'm or people working with medicines, drugs and medicines. How do you find building military craft if they're going to be used to sort of like bomb other countries and things? How do you deal with that sort of morally? Is it?
Yeah,
I mean, it's the same with me as a physicist.
sure.
We're doing subquantum kinetics, and that can be used for military as well as and the
Good,
same
good or
goes
bad.
for
Yeah,
experimental
yeah,
Yeah.
animals for drugs and things like that.
Well,
But
that's a it's a big issue, and it gets into the philosophy. And we're part of the problem with Stavatti is we're heavily rooted in philosophy, and we have a lot of philosophical documents and stuff. And so it's not just a straight business, and parties don't really like that. We've got kind of two problems going on. One is there's always going to be a need for defense against barbarian invaders. So if you're just minding your own business and your life is good, chances are somebody who's less sophisticated is going to come get you. It's
yeah,
not paranoia; it's just historical, a fact. And in our own case, you just publish anything, you get attackers. So there's there's a lot of trolls out there.
yeah.
If they have weapons and they have needs, that's bad. So just there's an underlying need for humans to defend themselves. The
and you kind of
problem,
just hope you're on the right side.
yeah,
You hope your fighters are being used for the good side, not the negative side. You know.
exactly. And so
Yeah.
that's a big challenge. And so, you can say that we only sell to countries the State Department lets us sell to. And there is a list. I mean, like you're not allowed to sell to Iran and North Korea. And, we're very well controlled from that perspective. However,
Yeah.
when you get into the issue of not wanting to sell to the wrong side, there's certain questions that come into play, especially in the case of Pakistan, especially in the case of other potential threat countries. And what Stavatti has done is we typically stay out of certain conflicts. I had mentioned Ukraine. We haven't sold any weapons to Ukraine. We haven't been involved in the fighting at all.
Yeah.
Maybe that's good, maybe it's bad. Vladimir Putin was asked if he's going to join into this whole fight with Iran or support Iran. And he said, well, there's about 2 million Russians living in Israel. And so we really don't want to hurt those people. And,
Yeah.
the same can be said, would Russia really bomb California? Well, there's a lot of Russians in California. There's a lot of Chinese in California. So
Yeah.
when we talk about this paranoia about being invaded by Russia or China, is that really ever going to happen? Well, probably not. Maybe yes, maybe no. It's hard to say. China is a really tough one because just about everything we own in the Western world is manufactured in China to some degree.
Yeah.
Chinese are really great people. They live under a communist regime.
Mm.
Communist regime does a whole lot of business with us, and there's this constant back and forth. So there's certain countries that we just can't sell to by law a weapon system.
Yeah.
But there again, it's always a tough it's a tough situation. We have a list of preferred nations, but some of those preferred nations have even exhibited severe totalitarian tendencies over the last 3 years.
Hmm.
So it's really a toughie at times.
Yeah.
And I think maybe that's why you're sort of trying to focus more on the airliner and the hover car and the SM-150, the civilian
Yeah.
aircraft as well. Yeah.
That
Yeah.
has a lot to do with it. That's where, there is a need for the military equipment. And the other part of the military side is it's such a political monster, and it involves such a high degree of lobbying.
Yeah.
So, the ideal customer for Stavatti, like at the Air Dominance Summit, I'll just give you an example. We had a lot of people there, a lot of representatives of the Air Force, the Navy. We had representatives from the Royal Air Force. We have the Canadian Air Force. But we also have the Portuguese Air Force.
Hmm.
And if you look at a country like Portugal, they're a very small country physically. They don't have a big air force. They have an air force. They have NATO commitments. They've flown Harriers. They fly, I think, F-18s, and they need new fighters. And so, in the case of Stavatti, Portugal really hasn't been known for going to war. They're really not a nation that invades other countries. Most
Yeah.
of their colonial history is centuries ago.
Yeah.
So an ideal customer for Stavatti on the military side would be a Portugal, in the sense that they need airplanes, they need good airplanes, they need affordable airplanes, and they have commitments that they need to make, but they're trying to defend their country from unknown potential threats in the future. And so that's an ideal customer.
Yeah.
Provided they don't have a political upheaval, which they probably won't. It's
They're
always
pretty stable. Yeah.
pretty. Portugal's been pretty stable. So, and that really eliminates a lot of the question of the moral issue of who you're selling weapons to. Of course, if I think the ideal wartime situation for Stavatti would be to have a country like Portugal that gets invaded from unknown threat, and you want to defend Portugal. So that's the idea. But do we want to make an airplane for a regime that is going to be an offensive party and conquer the world? No, you don't want to.
Yeah.
And you do. So there is an evaluation component. And in the case of the United States has there is definitely a need for our aircraft, whether or not they'll enter U.S. service. It's a long road to climb. I think there's different. We're competing for some Navy contracts. And the Navy has really been more of our focus over the last few years than the Air Force, although we could sell to the Air Force. But there again, ultimately, if we do begin selling to the Air Force often ends up selling the products. So it's not through direct commercial sale, it's through direct foreign military sale.
Will the SM-39 will that have the ability to land on a carrier? Like, will that be a Navy?
Yeah.
Okay, very cool.
Carrier, and we have a video that we're in the process of editing and putting together, showing it land on a carrier. And we've got about 50 videos we haven't released, and they're all just in different states of design. And
wow.
We ultimately, we've been working on all this video rendering stuff, and it gets super complex and super expensive really quick.
Yeah.
So we just said it's cheaper to build the airplane and videotape it than it is to do all these damn, movies.
Wow.
Are you a movie company or are you an airplane company?
Well, yeah, exactly. Right. Yeah.
These projects snowball, and so we're just, going to start filming some airplanes. So
very cool. Well, if you've got videos to share, we'll absolutely do that for sure. Well, great. Well, thanks again, Chris, for all your time. We spent a lot of time this morning talking to you earlier, and now this interview. I'm looking forward to doing it again, very much so. And it's always great to talk to you. Are there any closing comments that you want to add, or? Anything you want to
No,
say to everyone?
just thank you for the opportunity. We're out there promoting our message, and we're hard at work on these new projects. So
Yeah, very cool. Okay, well, thanks everyone for looking at Technology Envoy with Chris Beskar, the fifth interview that we've done. Some amazing information today, and also it's BJD, small BJD, lowercase 798. That is the Brendan's YouTube channel that this will also be on, but also the physics thing that we did this morning for everyone out there. We're going to put them up today, hopefully at some point on both channels. So thanks again, Chris, for joining
Very much.
us and looking
Yeah.
forward.
thank you
Thank
so much.
everyone for watching. Hope you have a wonderful rest of the day.
Yeah, thank you.
You bet.
Bye.
Okay,
Yes,
bye-bye.
bye.